Alright, to start number 23, I think I sniffed out a little typo, but we'll talk about it. It says, find the equation of a hyperbola. I thought we were boom. 3-1, I tried it, but it's a mess. It just doesn't work. But if we use 5-1 with these foci, it works. So let's make that a 5 and deal with that. So here's 1-1. Here's 5-1. You'll see that this is the only way that it'll work. The foci, remember, if these are the vertices and the foci are at 0, 1, it means your hyperbola is going to be like this, and 6-1 is the only thing that would make sense. So this definitely has to be a 5. So that would be right there, meaning it's going to be like this-ish. We don't know to what degree because we don't have our box, but here comes some clues. First of all, 1, 1, 5, 1, we know the center of that's going to be 3, 1, which gets us off to the races. We know it goes this way, so I call it the Pac-Man. The Pac-Man are gobbling up points on the x-axis. So generically speaking, we know it's going to be x minus 3 squared over a squared, because it's going along the x direction, minus y minus 1 squared over b squared equals 1. So that's a lot of information already. Well, first of all, if this is part of our box, we know that this is a, and that's 2. 2 in that direction, and it's 2 in that direction. So we know that a squared is 4. So x minus 3 squared all over 4 minus, we're going to keep this as is, and we're going to keep this as is. Now we're on the hunt for b squared. Well, a squared plus b squared equals c squared is going to be our go-to. We know a squared is 4. We're trying to find b squared, so we must be able to find c somehow, and we can, because that's from the center to here. So if this is 6-1, which it is, and this is 3-1, this is the distance from the center to the foci. That's 3. 3 squared is 9. So if I subtract 4 from both sides, I get 5, and that's what b squared is. So we can be done with that problem right there. Okay, you can see we're entering into the world of parabolas. So here's a bunch of stuff you just need to know generically speaking. Every parabola has a vertex, that's the turning point, and it wraps itself around the, I called this the tulip when I taught it, wraps around the focus, and it blossoms away from the soil, which we call the directrix. And this is true no matter whether it's up, down, facing to the right, facing to the left. Y equals x squared, happy face if a is positive, sad face if that's a negative. X equals y squared, if a is positive, goes to the right, if a is negative, it opens up to the left. So let's look at this. Everything is just kind of spoon-fed to us, but we got to find all of these pieces. Oh, the thing I didn't explain was this distance is c, and that's the same thing as that. And we have this formula, a equals 1 over 4c. And remember, we'll talk about that in a minute. I shouldn't have written it like that. It's a equals 1 over 4c, so you know that 4c is in the denominator. It's not 1/4 c. Be careful not to do that. I almost wrote it that way. So, with that being said, this is left 3. And then pre-calculus started to deal with this a little bit different, but if I add 1 to both sides, I could look at it as up 1, because that's the way we did it in Algebra 2 forever. Or, if you don't like it there and you want to go with what pre-calc's talking to you about, so that'd be up 1, and if it's written like this, you'd have to think opposite. Negative means up. Regardless, the vertex is going to be negative 3, up 1. Because this is negative, it's going to be a sad face. This makes it wide, but they don't really care about that right now. They're not asking you to graph it. I'm just trying to give you a good, accurate drawing here. Where's the vertex? Well, we talked about that. It's negative 3, 1. Where's the focus? And where's the directrix? Well, we got to find C. We're going to use this to find it. Don't forget, C is a distance. One of the rare times in math you can ignore a negative, because you know that C is a distance. So we're just going to take 1/12, set that equal to 1 over 4c, and 4 times what is 12? 3. So we got to go up 3 to find the dirt. There it is. What's that thing's name? Well, it's a horizontal line, and it's up 1, 2, 3, 4, so it's y equals 4. And I need to go down 3, so 1, 2, 3, to find the foci. And that is going to be -3, -2. And we found everything. On this guy, we got some work to do. We have to decide, is this going to be an x equals y squared or a y equals x squared? Well, you can see the x is not squared, the y is. So it's going to be one of these guys. So what we're going to do is we're going to get this alone. We're going to move everything over. But actually, I'm going to move that over. It seems a lot easier. And I'm going to flip it around at the same time. So I'm going to go 12x equals y squared plus 2y, watch this, plus space, plus 37 plus space. Notice 2 blanks on the same side, so these have to be opposites. Now, I'm not going to divide everything by 12 yet. I would just mess everything up. To complete the square, we like that to be a 1, and it is. So take half of that as 1, square it, is 1. But if I put a 1 there, I got to subtract 1 there. This is my perfect square trinomial, so I get 12x equals y plus 1 squared plus, that makes 36. Now, I could divide everything by 12, but because we like a fraction in front of our squared things to identify what a is, I'm going to multiply this by 1/12. So that hits that hits that, and that hits that. So x equals 1/12, y plus 1 squared plus 3. Now we can get to drawing. Where's our center? Well, this is opposite, so it'll be left 1. If it's written like this, this is what we obey, so that'd be right 3. Now, pre-calculus might want you to think of it like this. Maybe the CLEP test wants you to think of it like that. This would be opposite if it was written like this. So you'd think left 3, you'd say no, right 3. So, I don't know why I went left 1 right there. I think I did say that. But anyways, I'll have to watch that video. This means down 1. But this is right 3. So 1, 2, 3, down 1. So there is how we get started. It's an x equals y squared kind. And let me show you my little cheat sheet. If a is positive, it's a Pac-Man gobbling up points to the right. That's how I memorize it. This is wide. They don't care about how accurate your drawing is, but at least we have a drawing. So, let's find stuff. Well, here's my a again. We already used the same thing, but so we can just look at that and say, hey, c is 3 again. So we need to go 3 units to the right to find the focus. There it is. That point right there, remember we said is 3, -1. So 3 to the right of that would be 6, -1, and that's the focus. And then 3 back would be our dirt, which would be this guy. And this time the dirt is x equals 0. Vertical line, x equals. Okay, number 25, find the equation parabola, focus 3, -2. There it is. Let me label it. Directrix, x equals 9. That's our dirt. So we know that this is going to blossom away from the dirt. That's huge. That means it's going to be an x equals ay squared kind, but a has to be negative. That's a big clue I just gave you. Now, how do we make adjustments because the vertex was shifted? Well, we're going to go x equals, we'll deal with that in a minute. So -a, we know that it went down 2, so it's y plus 2 squared. We know it went right 3, so I'm going to put plus 3. So the final thing we need to do is find a. Well, here's the clue. That right there is c. The distance from 3 to 9 is 6. So this time, we're going to use this formula and just put 6 in. So that's 1 over 24. Now notice, if you didn't recognize that this Pac-Man is gobbling up points to the negative x direction, you wouldn't have This will not tell you that your a is negative. The drawing has to tell you that. So we have to know that this is negative, so our final answer would be x equals negative 1 over 24, y plus 2 squared plus 3. There we go. Don't forget that, little guy. A lot of you will do that. Don't do it. Okay, I think these are the easiest ones. Circles. Remember, the generic formula for all circles is right there with center at 0, 0, and that means your radius, you have to take the square root of that to find the radius. So with that in mind, let's go. So remember, ellipses, they equal 1. Hyperbolas, they equal 1. Circles, no. It can be 1, but it can be anything. So let's gather some information here. So x squared plus 2x plus space plus y squared minus 10y plus space equals negative 17 plus space plus space. So take half and square it. Because they're on opposite sides, you got to do the same thing. Take half and square it. Opposite sides, same thing. Perfect square trinomial. Perfect square trinomial. And that's 26 minus 17, which is 9. So what's my center? My center would be negative 1, 5. My radius would be the square root of that number, which is 3. That's it for that one. Here's another one. Gather your x's, gather your y's, and that equals 1 plus space plus space. Take half and square it, 9. 9. Take half and square it, 16. 16. And we get x minus 3 squared plus y plus 4 squared equals 26. So the center would be 3, negative 4. And the radius would be the square root of that, because that's r squared, be the square root of 26. Remember, r squared equals that. So take the square root. Boom. This one's a little bit easier. It says write the equation of a circle with center 2, negative 7. So that's pretty easy. X minus 2 squared. Don't forget the squared. Y plus 7 squared. And if this is the radius, remember what I said, we have to put r squared here. So if this is radius, we have to square it. 5 squared is 25. The square root of 3 squared is 3. And that would be 75. And you're done. Those can be pretty easy. This one, a little different, but it says 5, 1. So that we can get started at least. X minus 5 squared, negative 1, plus 1. And now we got some work to do. 1, 2, 3, 4, 5, negative 1. It says negative 2, 3. Negative 2, 1, 2, 3. Now, we could use the distance formula, but look, guys, if the center's here and it goes through this point, it's trying to get your brain to look at this circle like that-ish. So if we can find that distance, that will be our radius. Well, I'm going to go old school on this. All I'm doing is using the distance formula without using the distance formula. I'm just using geometry. So I'm going to build a right triangle here. So from negative, whoa, what did I do? Hold on. Oh, I just labeled it wrong. Darn it. Sorry about that. Yeah, you guys must laugh sometimes. Negative 2, 3. No mocking. No mocking allowed. I hear you laughing. 5, negative 1. There. So anyways, back to this whole speech about building a right triangle. So this is 5. This is negative 2. That's 7. This is down 1. This is up 3. That's 4. So I can just use Pythagorean theorem. In fact, that's all the distance formula is. If you want to use the distance formula, you can, but guess what that is? It's just Pythagorean theorem. So a squared that distance, plus b squared is r squared. So this is 49 plus 16, that's 65 equals r squared. You're going to want to instinctively take the square root, but don't, because that's what goes there. R squared is what goes there. So there you go. All right, we're going to squeeze number 29 in, and then we'll finish this particular video. Identify the type of conic. Well, it wouldn't be a terrible time to have your worksheet out. Let me get it. So I didn't mean worksheet, I meant formula sheet, just to look for some clues. Now, I'm going to use this. You can refer to it if you want, but notice we got a minus for hyperbola, squared squared, we got ellipse, plus squared squared, circle squared squared, but notice this is like over 1, this is over 1, these are the same. We'll talk about that in a minute. And parabolas, one variable squared, one variable squared, and one variable isn't. So with all of that in mind, let's find the parabola. That's the easiest thing to find. And I think we found it. Because look, one variable is squared, one isn't. So that is a parabola. We can take that off our chart of things to find. We got 9x squared minus 4y squared. Quite honestly, nothing else matters. Here's my squared terms. They're not the same. One of them's a plus, one of them's a minus. That immediately is going to be a hyperbola. Then we have two things squared added, and these are not the same. So that's a whacked out circle. What name do we give that? An ellipse. Well, by process of elimination, they must be hiding a circle here. And if you're like, oh no, that's a minus and that's a plus, that might be a hyperbola. If we just add y squared to both sides, we would get x squared plus y squared. Everything else doesn't really matter. Minus 6x, I could bring that over, plus 2y equals 10. We could rearrange this, complete the square, and prove to you that it's a circle. But notice this is a 1, that's a 1, it's all over 1, all over 1. We have perfect balance with a plus. That makes this a circle. Done with 29.